Ocaml. Now, I know Pick is going to die a little bit that this isn't Haskell, so can you show me how to use not Haskell here?
Yeah, so we'll start in lib, which is where
Okay.
all the interesting stuff is right now. I'm a little farther because I wrote some of the other parts of this too, and I've been pushing them up. But we can just go to token
Okay, let's start with token.
first. So you got just like the kind of types like enums that you expect to have,
Okay.
for when you've got in Rust, and the enums can all hold different data types,
Yep,
which is
so that's
nice.
what that of is, right? That of is just
Yep.
saying, hey, I'm an enum with this inner type this.
Right, and so I've got a string inside for these things, and then the other ones you don't need to keep around chars or anything. Like what I mean?
Yeah.
Like if you have real data types, you just pattern match on them, and then it's good.
Yep, that makes sense. Okay, then you have a little lookup right here, which does effectively a quick lookup right here, right? So it just simply goes, okay, here's all the matches that are keywords returned. So you don't even have to have a map. You can just have this. So you don't even have to compute a hash. You're just doing small string checks, which is probably faster than doing a map lookup anyways.
It's going to be fast because the compiler is good for this, right? So it'll be really fast for this.
All right, can you explain this really quickly? Deriving
so
show and equal.
Yeah, so that's basically macros.
Okay, so that takes the previous item, is my guess?
Yep. Mm-hmm.
Okay, and this allows you to print it, and this allows you to call equal sign on it. Or
so they generate new functions. So they'll generate a show function in this namespace. There's like a show function which returns a string, and then there's like a pretty printer function which you can use to pass to like formatters.
Okay, that's pretty cool. Okay, okay, what's the next thing?
So one thing that's cool, I'll just show you quick in the elixir.mli. So these are interface files.
Oh,
so this tells you what like the public interface is for the Lexer. And what's cool
so this is like
you can
equivalent to a header file? Is this like a header?
It's kind of like a header, except it is in some ways, but you don't have to define everything. I guess you don't have to either for like a header file.
Yeah.
But you can have a bunch of functions, and nothing in the actual implementation file cares that it's not in here. It just has to match this, and like it gets type checked and everything.
Oh, nice. Okay, so you can give it a light type checking of the file, but the file itself can be vastly different as long as it contains this. This is the subset of what is contained in the file. And does that mean when you import it in, you only see the subset?
Yeah. So you can't access anything else. The other cool thing is like, see how it's just type T?
Yeah.
Like I actually have a T type with like the implementation in the actual .ml file.
Okay.
But like this makes it so you can't construct one on your own. Like the only way to construct the type, the only thing that will pass the type checker and allow it to be compiled is calling init, which returns a T. So there's no other way to get a T, right? Which is this type. And then like the next token thing below, this is the only thing you can do with this type, which is called next token on it. And you get back a new parser and optionally a token if it's done. So like the star is denoting like a tuple.
Okay, so quick question here. So how do I read this? So I have a value, a init, string. So does that mean you've attached the init function to string?
So init, so it's saying like name is on the left side of the colon, and then the right side is the type definition. So the type definition is a function that takes a string and returns a T.
Okay, I can see that. Okay, so this one.
So the next one is a function that takes a T and returns a tuple of T and optionally a token.
Interesting. Okay, and then what's this last one?
That one is like, there's this kind of, you'll see this if you do it a bit more with Ocaml, but basically it's a formatter style thing that you use to pass into like the way that you print values. So this one's just for pretty printing stuff. You can use it to pretty print.
Okay.
So now we go to the ML. So now you see we have a type T, and we actually say what's inside. No one can access those. Those are all private.
These are how
because
you do
I did type T. I could show it if I wanted, but I didn't.
What is that? Is that like effectively the new line comma that you see in old Node code?
You can put them anywhere you want.
Okay.
Like the like formatter style that I have, it just does this because I like them to be aligned. So I don't know. That's just the way that I have it.
Okay. So here's
you can see
that takes an input. If the string is empty, we just return back. If this is empty, then we return out effectively a input position 0 chars none. Else, we do input position 0 char is some string input first character.
Yeah.
So you're effectively doing read char right here.
Right. I did mine slightly different because I wanted to see if I could do it without read position. I've done this already like twice, right? I didn't
Yeah.
really get why we keep around read position because it's always just position plus 1.
Yeah. Yeah.
So I wanted to see if I could do it without that, and that's basically like just the way. People are wondering about the double semicolon. You don't have to put these. There's a few formatting styles that I just like from what I've seen so far. And like the auto formatter does it for me. I don't write 2 semicolons, but it like clearly separates when a function starts and ends,
Okay.
so that you know that you're completely done with this function, right? Because
Yeah, there's no squirrely brace
parentheses
or anything. Yeah. Okay.
right. So I find it helpful because then it's like super obvious that, okay, sweet, this one's all done. Now I'm going to start the next one, right? It's just like visually clear that I don't need that.
I do say that the one thing I find right away with this language is that there's not a lot of symbols, and it actually makes it a little hard for me to kind of put myself in the right headspace.
Yeah, it does take a little bit of time to like get to figure out what exactly like is happening at first, because there's some stuff that's quite different, like no parentheses and things like that. But then you start to just like, especially with a good syntax highlighting thing, you just like know, you see like, oh, I have my color for my function. It's like super obvious, and then you get going on, right?
Okay, so a couple questions here. Rec stands for recursive.
Yep.
You have to define when a function is recursive.
Yep.
Interesting. What's in?
So let statements must be followed by like basically an expression at some point. So you can't just like define a variable and have it hang into nowhere without it. So like let statements let you're basically like creating a new variable in the following scope. It like makes a scope further down. But you can think of the in basically as like a semicolon in most languages. So you're saying like let parser equals this in this next expression. Let open token basically just like it moves that namespace inside. It's like include or like use in Rust. Yes, that's a better way to say it. Antonio is right. It creates an immutable binding to an identifier because they're not variables. You can't change them. They're identifiers, right? So everything's immutable by default.
I'm too stupid for Ocaml.
No. You got it. You just remember that in is just a semicolon. Then it's fine.
In's not a semicolon. Because you then type in at the end of your function if it's just a semicolon.
I can write a Vim plugin to change all the ins to semicolons for you, and it'll look the same.
The Prime is stupid Ocaml plugin just to make me feel safe and warm. Okay.
Yeah,
so
we'll toggle Prime mode on and off.
Okay, so really what this is saying is this pointer to a value will exist for the duration of the scope that it's in, which is this function parser.
Yeah, basically, yeah.
Okay, so explain to me why you have next token, which takes in a parser, and then you shadow parser by saying skip white space, which takes in a parser and then returns back out the parser.
Yeah, so the parser never gets changed. Like each parser is immutable. I wrote it in a style just to explore like what it was doing. So if you go back to the type at the top of the file, type T like is the parser at the very top. If I wanted to, we could have changed this to make position and char like on the ch. We could have said that those are mutable. So like you literally put mutable in front of them, and then that tells you that those fields are mutable.
Then you'd be able to plus equal them and all that. But you decided to just like, can you do this fully immutably?
Right. I just wanted to see, right? Because like that's in general like more of the style that you would do, because it lets you it lets you reason very clearly about the functions. The functions always take in a parser. If they can change the parser, they return a new parser. If you don't use the results of a function, that's an error. So you can't just like call skip whitespace on the first line there and like not do anything with the result. You have to at least you would have to do like let underscore.
Is it one of those?
Yeah, you could do let underscore.
Okay. Oh, you have to do let underscore.
Yep.
Wow,
you could say that. That would be okay. And then it would be an error because you're not doing anything, right? But like, I just wanted to see if you could. I think you would write this in a different style, maybe if you were more focused on doing it like immutably. Like there might be some things to make it slightly easier.
Okay.
But I was just seeing how I could translate it and see if it was possible that I could still get the same results and write like a completely immutable parser. So every function is a pure function, right? Like if you give a parser and you call next token with like a certain state, it will always return the same next parser every time.
Okay, so in some sense, it's a little bit easier to reason about because there is no such thing as state. There's just arguments.
in the way that I'm writing it. You can write it more like procedural style, where you're mutating the parser in place. But the compiler sees what you're doing here, where you're taking a parser and returning the parser, and then now that I'm shadowing it, it's disappearing. And as far as I can tell, the parser the compiler does smart things with that to like make sure that it's not just like copying everything all the time.
Okay, can you explain this really quickly? Let open token in.
Yep. So when we go back, if you like, we're back in the token.ml file, which we can just open really quick.
Token.ml file,
yep.
yeah.
So like all of these variants where we had like left brace, all these other things. If I didn't do let open, I would need to put like token.assign. But when I do let open token, that just says basically like open this module. Files are modules, right? So it's like the same. You can actually make modules inside of files, but files are also modules. So opening the token inside of this expression lets me just put like 5 lines down. See how it says semicolon? I'll switch this way. Like I don't have to put token.semicolon there. I would also not have to put it after the first one because Ocaml's like type inference can tell, but I just think that it's kind of nice. And that's only like in the following statements, right? It doesn't open it for the whole file, just for the following statements.
So what you're trying to say, let me just try to say this back to you.
Yep.
That the values that are in this file, here, hold on, let me harpoon myself here. I'm getting all confused. There we go. Yeah. Okay, so effectively, these values right here and lookup identifier, those values are now scoped into this function because you opened up capital T token, which I don't see that.
So the name of the file is token.ml.
Yeah,
so like it creates a module capital T token.
Okay, so so I see this. So you are opening it, and effectively all the contents within it are now available specifically within this function, is what you're trying to say.
Yes, but specifically for like this statement.
But it's not open everywhere, right? It's not available everywhere. That's why you do open base. Is that effectively like import standard?
Yeah, basically. Yep. So that I don't have to write like base.list.iter or something like that. Yep.
Okay. So it actually so that means there is some problems with like namespace collision stuff that could happen.
Yeah, the compiler will tell you like if it doesn't match. So like let's say, you try to use a name that doesn't work in like the right side of these parentheses, like even though I'm not saying the type anywhere, it will know what the variant is that I'm doing, like that type that I showed where I have like semicolon left, right? If I just added one that doesn't exist, it won't compile.
Okay, how does it know that it's using token, by the way? Is there some sort of inference going on where you don't have to do like token dot, or I'm not sure what the proper syntax would be?
Yeah, you would do that if I didn't do open token. Yeah.
Okay, it just but open token is because what's this thing called? This thing is type T.
Yeah. So for variants, you don't do like T dot function or T dot. You just like the names sort of get. I don't know what the right word is. Maybe I think Antonio's
it's
here, but like maybe
C style. When you do an enum, you don't go like the name of the enum dot the enum item. You just go the enum item. It's like now.
Right. Yep.
Okay.
Yeah. And so if there's collisions, it won't let you do that. Like the compiler will just tell you that those don't work. You have to namespace them more.
Okay. So that's when you would drop this. You drop open token.
Right.
I don't know how to do I don't know how to do comments in this language. But you drop that thing, and then you would be able to. Okay. I see what's happening here.
Yep. Yeah. So then you can see the rest of the like match statement, right? So I changed mine to be slightly different from the way that like it was in the book, where now like I call advanced parser that returns a parser that's advanced one token.
Right? Yeah. Let's see.
Right.
That means let's see. Hold on. If a position is greater than string length -1. Okay. So there's the +1 is right here instead.
Yes.
It's not a
exactly.
-1. That means it'd be a none. Else it's going to be position equals parser +1. We're going to bind to that, and now we need to do parser with position, meaning that it effectively takes your parser and merges in the position variable.
Yep.
And it merges in this variable as well, right?
Is that so that's the same thing where you can do like if the name of the variable is the same name as the field, then you don't have to say position equals position, right? So I could have said parser with position equals position, but you don't have to do that.
To write this in a different language, it looks something like position equals position, right?
Yep. Right, and then parser dot
ch if this was TypeScript, you'd do something like that where you'd spread the parser because you're creating a copy, and then position equals position, blah, 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 blah. Okay, I see what's happening here, and that's why you do an equal sign because this doesn't have a value. But if you wanted to do, if you want, If you wanted to do that, you do something like this. Let whatever.
Yep.
Oh, I did the wrong thing. That's from earlier when we were trying to be smart.
Yep.
What would you do? You do this in, and
Yep.
then I would just do.
Yeah, you just do that. Exactly. Yep.
Okay, and then this returns. And then okay, so one more quick question. Why is there squirrely braces here and parentheses here?
Well, both of them have squirrely braces, right? Because they're both returning a parser, which is like a record.
Oh, if this was multi-lined, it would look like that.
Yeah. Well, yeah. If it's like
this is actually the type that it's returning a new part. Oh, okay.
Right. Multiple like statements or whatever, I guess.
Yes.
I don't know how you would say. I don't know if that's the right word, but
I just use the word lines because I don't know if it's expressions or statements or however they do things.
Yes.
So I just
I don't know. Everyone's mad at me. Haskellers are mad. Ocamlers are mad. It's all the same. But yeah, okay. So you see what advanced does, right? It just returns a new parser with the updated position, right? So it calls advanced. So then if we go back to like the match statement, you'll see like those are the ones that advance.
Yep.
Right. And then I have one that basically does peak where it says like, hey, what's the next thing? So it's like when you get to bang, it's going to say, is the next thing an equals? If it is, then it's going to return not equal. Otherwise, it's going to return bang. Right. And those are named arguments.
Oh, interesting.
Is like the.
Oh, hold on. Sorry for saying this. So peak.
Yeah.
So what you're saying is, does peak equal this? If it does, it's. Wait, no.
So those are all getting passed to the same function. So like if you go to, there's a function in here called if peaked. You can just look for if peaked.
Oh, if peaked. Oh, sorry.
Yep.
Okay. So I don't get these tildes. What are these tildes?
Yeah. So that's how you do named arguments. So like if you want to pass it with a name, then you can do tilde default, right? And then it's got the same sort of thing as well, like where if the names are the same. So like if you had a variable called default and a variable called match and you called if peaked, you can just do tilde default. And it will know, it'll like put those together. Same way you do with records.
And then you advance at the end in which you would.
That's the same thing that you're doing when you read like
you do one more advance. Okay, yeah, because you have to double advance because
right, because if it's bang not equals, right?
Yeah, holy cow. Okay. I think I'm starting to see. I think I understand how this works a little bit. This feels in my head. This feels a little confusing.
Well, yeah.
I mean,
there's a lot
I'm not
more
used to it, or if it actually is really awesome, right? Developer ergonomics, right? Is it actually useful and you just don't get it because you haven't done it enough, or is it actually really not that great? It's very hard to tell when you're new to something if something's bad or you're just bad.
Yes, agreed. Yeah, it can be difficult.
Okay. And this is how you do named stuff: is you do tilde the name and this. Okay, I like
named
stuff.
I didn't have to do that, but I felt it's a lot easier because, like, which one do you want to do first? The one that matches when it's peaked, or the one that matches when it doesn't peak forward? Right? Like, I don't know. I couldn't figure out. Well, neither one made more sense to me, right? To put as the first thing, and they're the same type, right? Because they're both token. They're both like the token.t type.
And then you can do when char is an identifier. You can read the identifier with the parser, which returns back out a parser plus one more item, right?
Yeah, no, it returns the parser and the like token.
Okay. Oh, let's see.
That's what each of them do. Yep.
Okay, then you have to do this in at the end because of why?
Because basically whatever gets returned here.
Yeah.
Right. Then we're going to return. It returns a parser and a token.
Yeah.
Right. And the result of this function, I want to be parser and like a token option.
Where do you assign that? So that's where I'm kind of confused. Is this match statement? Every branch is returning two things, or it's the expression resolves into two values. But I don't see something like let parser token equals this. So I'm confused at how is it assigning to something?
Did I have that earlier? Now it looks like maybe you deleted something. Let me just see what.
Here, just to make sure. Here, I'm gonna go like this. There we go. Load file, just in case I did something.
Yeah, just in case. Otherwise, I'll
no,
look
no,
later.
no. You did.
Okay, so that's fine. So what happens here is the Well, let me see. Where did we? Oh, sorry. The in. When you scroll down, I was like, I don't know what you're doing. The in is indented in one. It's in the match. it's in the match for the sum.
Oh, it's in right here. Oh,
Yeah, I was like, that doesn't make any sense.
Yeah. So this is one. Okay, so a good follow up here. This is why I tend to really like some sort of ending token for various statements, because then you have to play the game of indent looking. I see what's happening. This is actually defined right here. Right?
Yeah.
This is the result of this match statement in which you're returning right here. Okay. Perfect. I get this. And so then both of these branches return this, which this is just auto being returned.
Right. Yep. Okay. And there is no like return keyword. You can't just like
I know, which
return.
is unfortunate. It's gonna be a struggle bus for me, but I'm gonna get it.
Yeah. Okay, so that's next token, right? So I mean that's pretty much it. You can look at like what does read identifier look like. So I don't know. This is where maybe you won't really like this. I don't know. We'll see. Oh no, this one's fine. Yeah. So it's just like the thing that you do here, right, is I have this function read while that just like seeks forward in the parser, right? And notice they all return parsers.
Okay, hold on.
So
Read
like,
while read while this must be something you've made, right?
Yeah.
Okay, it takes in a
It's right
parser
there.
and a condition. Okay, the condition is a function.
Yep.
Okay, so it's just keep reading the parser until it's done, then it returns out the parser and the ident.
Yep.
And it does that. So that means number is the exact same thing. Read while is just the exact same thing, except for the condition is number. Return that. Okay, that's straightforward. I like that. That's beautiful.
And like the cool thing about these, right, is like you'll notice throughout this thing that like I didn't have to write any types.
Yeah, you really didn't have to write any types ever.
I didn't write any types, basically, you know what I'm saying? But like if one of the case statements in the match didn't match the right type, it would error. Like it wouldn't compile.
Interesting.
It's like if instead of
pattern matching is a large amount of the checking of types.
It's not so much the pattern matching. I'm just saying like so the first match on line 20, right, 4 lines above you, match parser.ch. That's the thing that's basically getting returned from next token, right?
Yep.
And what you see is the first case is I return a parser and then an option.
Yep.
So like if the other one doesn't do that, then it will be an error. And it'll say like you have 2 conflicting types for this function return. You can't have that. That is not allowed, right?
Okay, and it knows the types because you have this T right here. I also noticed that you use type T more than once, which I'm a little confused about, like why that is. But it's say like next token operates over types T.
Yeah.
And token
that's like
option.
Lexer.t basically, because we're in Lexer scope, right? And the other one is token.t. It's a convention that like if you have a module, a lot of times if you have some sort of like exported type, that is the thing that gets like used. It's like the primary focus of that module, because modules can contain more than one type, which like this thing does, and like I define other ones later and have it, right? Then you just usually use .t because it's kind of nice.
Interesting.
It's like the convention that you would do, but you don't have to. You can do anything you want. You could have called this type Lexer if I wanted. There's nothing special about T.
Okay.
It's a convention, though.
Interesting. It's I guess I don't, because in my head I'm trying to reason about how does that work with a lot of types and all that, and how do people that import a bunch of stuff, blah, blah, blah. It doesn't really matter. It's just very interesting to me, like how little types were specified here. But there is some level of specification that is going on. And
no, there's like, it's 100%
little.
Specified. Like every single line has one and only one type that anything can actually be. There's no like...
Yeah, but it's so it's forward inference, which is very interesting. That's very, very good. It's able to take this line and then it just keeps on inferring all the way through, which I'm very
right.
Okay, I like it.
So you can write types in the file if you wanted. Like so, for example, on the parser, on advanced parser, like on 3 lines down here, if you put like a left parenthesis around parser. And then go over to the right and do a colon inside of there and do :t. Like that's valid.
Oh, okay.
That's
so you're just
what type it is.
You're just saying explicitly, hey, this is type T.
Right. Which can sometimes be helpful. Like sometimes you want to write that type and you say like this, right? You can do that. And that's good. Someone was asking what's with the and at the beginning of these. You can basically make one big let statement and use functions interchangeably throughout it by using and. So like functions don't get hoisted. There's no like special top level hoisting of functions, But if you want to have functions be able to like intercall between each other, all of these are part of like next token. So they're kind of like, you can write them with ands together, and you can call them in any order. I think it's called chaining or something like that. I don't remember the word.
Okay, and so you don't have to have if peaked defined below peak char, because it just goes, okay,
right.
We know we
yes,
get all their
exactly,
definitions
right, because they're all part
then...
of the same statement. Otherwise,
okay.
you do need to, right? Like, because it makes sense, because you need to know the type of something, and you can shadow the name, right? So there's no way that you could know ahead of time what like it's going to be unless you've already seen it.
Okay. I also noticed that you said this thing is recursive, but it's not. I don't see anywhere in which it is recursive.
There's something kind of a little bit where you have these like where you have these chained things together. You still have to say that it's recursive, because it's kind of calling itself with the other
it's
functions.
recursive in nature, that the sense that there's other things that it's calling within its definition, this and business. So once you have ands in which you're calling between, then you have to say, hey, it's recursive. Not maybe in the sense that I would use the term recursive.
Yeah, I mean, you also use the same exact word and the same thing if you're gonna call yourself.
Okay.
Like I have examples of that in like in the parser.
We're not looking at the
like
parser
expression. I know. I'm just saying but so yeah, that's where it gets exciting. But that's fine.
All right, this has been good. This has been awesome. Thank you for the Ocaml look through.
You're welcome. Chat was really mad. We had a lot of Haskell nerds really upset that we were talking about Ocaml, just really flaming it. But too bad.
Yeah. What do you rate Ocaml in this situation?
So the way that I wrote it, I think is not as good as you could write it for Ocaml. There's some really good like Lexer and parser like libraries that let you write really nice things. That you could write in like a lot less stuff and a lot less lines, like more succinctly. But I'll still give it. I think it's really nice. For just the Lexer, I don't know. Yeah, we'll rate it Dune out of 10.
Dune out of 10? Yeah, I saw the Dune thing going on. In my head, I'm like, how many Dune jokes can I make?
Oh, there's a lot. So Antonio, maybe he's still here. He's the maintainer of Melange, the spice from Dune. And that's one of the things that you can take Ocaml and compile it directly to JS, like in the compile step. It's a different backend for the Ocaml compiler, basically.
I'm trying to remember all the names. Cool. I can't remember any of the names except for the Bene Gesserits. That's it.
Yeah, the Bene Gesserits.
That's all I can remember from it. And then, of course,
I'll rate it Glorious
Atreides.
Emperor out of 10.
Yeah. Gosh, what is the dad's name? Something Atreides.
Duke.
He was like, really? Is it?
No, he is the Duke.
I know he is the Duke. Okay. Leto, I liked the dad. The dad is like one of my favorite characters.
The dad is so good.
The dad is like so good. They even made him good in the movie, which was shocking. Which is because they usually just make every strong character like that just completely impotent. They actually made him strong.
The movie was so good
in both ways. I love. It was so good.
The movie was good. The next Dune in IMAX for sure. I made the mistake of not seeing it in IMAX, but I'm going to go see it for sure.
I was shocked at how good Dune was, the movie, because the book doesn't make sense to be a movie, but they made it a movie.
It seems impossible to make it a movie. It's only people talking in their heads 90% of the book. Like
it's just someone thinking about what's happening, and that's it. Like they even made it, what's it called? Like when Paul's in the cave and he starts seeing into the future, he starts really understanding what's going to happen. They even did like a good job with that one, which was shocking. That scene, which was impossible to do well, they did it well, and I was just like, dang, this is so good.
I did not like Doom Part 1.
Thank you.
Get banned.
You didn't like it? I liked it. I thought it was great. My kids even liked it. I watched it with my kids, and my kids even liked it, which is really weird because it's a very kind of like thought-provoking movie.
There's like action, but it's not like all action the whole time. Yeah.
My favorite in Dune is the MILF org. Oh, no. The Bene Gesserits? Is that what he's trying to say?
I think that's what he's talking about, which is a little weird.
I don't know.
A little weird.
That's all I have to say about that one. All right. Hey, can I show you one thing then? Can I show you Zig since we're here?
Yeah, well, I was interested. Can you give me your final thoughts about Ocaml? I wanted to know your first thoughts after seeing it, like,
Okay.
Something in it for real.
Again, I think for me, when I see Ocaml, it comes down to a simple problem, which is I don't know if I'm bad or what you did is bad. I'm so inexperienced in it. It all makes sense what you did. The continuous immutability always worries me, but I may not understand how it actually works. Like
it is
it
not
actually
the same as like JavaScript.
It's not the same as JavaScript, which makes sense. And so there's all those problems that I'm trying to wrestle through, which I don't like. I wish they did a couple things in Ocaml. I really don't understand why people don't want opening and closing to any sort of scope. Like, I just think it's really easy to read and keep track of where you're at.
Oh, like brackets, you're saying?
Brackets, right? Like, it just, there's no need to try to have to look at this and try to figure out what am I returning from? Like, where's this value going?
Yeah, you can put parentheses around that if you want.
Okay, so you could theoretically go, you could do that, which you wouldn't do, and you do something like this, right? Is what you're saying?
Yeah.
Okay,
yeah,
that makes me feel better, because for me that's like a huge hindrance in just a lot of things I do. What about at the function level? Can I do a parenthesis here to here?
Oh, I don't know. You would look like a big goofball. But
you would, but
probably it would work.
For me, it's so easy to visually see what, like right here, it's very like, because both of us got tripped up on this line, right? We both got tripped up on this line because it's you don't get that extra information. For me, that's super important, is that extra information. I'm all about low cognitive overhead in any language. That's why I do like explicit returns. I don't want to have to think what is going on. And so for me, it's very important. I could have written
it in a different way that would make it be like less obvious. But yeah, the thing is, like, the compiler will yell at you though if you do it wrong, right? So that's one of the nice things. Like, it's not just like it's going to silently change the inferred type of the function, like in TypeScript, right? Like, so there's a lot of things where some of the problems that you feel like, oh man, this would make me accidentally return the wrong thing all the time, and like I'll just get screwed in prod. That's just not like a thing.
Yeah, I like that about Ocaml. I saw that about it. I like the typing system, which almost feels like you're just not typing anything here, which is really hard for me to understand, because there's, like, if you're looking at this, there's virtually not a single stated type anywhere in here.
There's none in this whole file.
But it is, well, there's like, at least is string empty, right? Like, at least you kind of give away the game a little bit there. And so that it's very interesting that just this small amount of typing can make all of this look typeless. So that's like my thoughts about Ocaml, which is, I'd have to get used to it.
Pixel brings up a good point too, where you could just write reason then. Like, you could look up reason. We don't have to do it right now either. But like, reason ML is literally just like a syntax variant of Ocaml that has what you're asking for, which is like brackets and things like that. Yeah.
Because that's always, because again, it's all about cognitive overhead. I don't want to have to think too hard. Right? Because that's like a huge, I call it search fatigue. Like, I don't want to have to unwind my stack in my head to know where I'm at. I kind of want to be able to just always have something that cues me in, like, okay, I'm one indent in while I was in a match statement. Normally I'd see, like, that's why I have the little cookies up there. So normally this should like, if I have this thing set up correctly,
you could make it show that.
It'd show the match
like,
as well.
Could make it.
And then I'd know exactly where I'm at. And so it's like, I'm always trying to reduce the cognitive overhead. And I assume that I won't, look at that. This one even does this right here. So we're getting close. We're getting close. So I wouldn't need these if I can just get, look at that. Oh, hold on. Let me just really quickly. I wonder if does this thing break if you don't have that? There we go. Okay, well, so this thing does show me. So I probably wouldn't need them long as I can have that. Yeah. Now that I'm getting a little bit more used to it.
The other thing is too, like when you have the LSP set up, it does do the like inlay hint things like above the functions.
Okay.
So you can, like, I write all my code with thinking about the types. You know what I'm saying? Like, all the types are just there, but the thing is I don't have to write them, which is really nice for when you want to change them.
Yes. The more typing you type, the more changing is difficult.
That's the thing that I find really difficult with Rust is like, okay, so let's say I want to change something that's like 5 functions deep. Right? Like, I have all these functions, and then I have this inner function that's called by all these other functions. Yeah. If I want to change what the interface of the inner one is, then I have to go and change the one of all the out ones as well. But that's pretty hard to do. Like, there's not really an LSP way to do that. I'm not renaming the original type. You know what I mean? Like, I'm just changing the type. Right? So, but in Ocaml, if I don't use anything, if the inner function is the one that like narrows the type to be like, Lexer, and then I change it to like Lexer plus plus, or whatever, something dumb like that, then it'll just infer the types all the way up, unless I have like stuff in an MLI, like an interface file or whatever. But it just makes it feel so easy to change everything. That's why that's kind of like the difference that I feel when I'm writing Rust is like, oh, I'm writing this, I want to change stuff, I'm doing it. Someone's saying explicit is better than implicit. Everything's explicit. The compiler explicitly says everything that's going to happen. And it will error if it's not right.
Yeah, I'm fine with type inference if it's a good language to do it. I've never liked it in TypeScript because it's not a good language.
Bad.
Because the problem is that the moment you deviate, it just goes, oh, that's cool, we're now this or that, right? Like it puts the onus on the caller to get it right, whereas this one, it still looks like it's putting the onus on the definer, which is what I want. But you don't have to spread the logic. So I'm totally fine in this direction.
Right, and it doesn't do like the dumb TypeScript thing where it just like unions things when you return it.
When you goof up, it's just like union.
Right, it's like, oh, I was returning an int, and then I had this if statement that accidentally now returns a char. And now it's like, well, you just return ints and chars, buddy. And no, that's not a type.
And then all of your usages are expecting numbers, and you're passing them all in that way. So nothing's currently looking like it's failing, but you don't even realize you've just like are spreading around